Hello. So today I'm going to be quickly going over what the main evidence is that we have to support the Big Bang Theory and why scientists are all behind the Big Bang Theory being the truth or accepted explanation for the origin and expansion of the universe. So it really all starts with, what did Hubble observe? In the 1920s and 30s, Edwin Hubble, who we talked about last week, observed that all of the galaxies are moving away from each other. It's like when you are baking chocolate chip cookies. Everything is moving away from everything else. And you'll see that in another station today when I talk about balloons. The fact that everything was moving away from each other is how they proved that the universe is expanding. So no matter what you believe about why the universe is expanding, everybody agrees that it is expanding. So the idea for the Big Bang comes from, if we see, okay, everything's moving away from each other. If we rewind the tape, if we run the clock backwards, then everything is coming back together and it's all expanding from one point. If you go back far enough, if you keep rewinding far enough, then all matter in the universe was in one tiny, incredibly hot, incredibly dense ball that is now expanding outwards. So something, a bang, caused that ball of all matter in the universe to start expanding and cooling as it expands. So the number one explanation, or the number one piece of evidence to support the Big Bang Theory, is the fact that everything is moving away from each other. Number two, we've got the high concentrations of hydrogen, helium, and lithium. These are the three lightest elements. They are elements 1, 2, and 3 on the periodic table. And when we look anywhere in the universe, these are the elements that exist the most. These are everywhere. Hydrogen is everywhere you look for it. Helium and lithium, a little bit less than hydrogen, but still, they're just absolutely everywhere. So in the first couple of minutes right after the Big Bang, up to the first 100 or 100,000 years, the conditions were just right for nuclear fusion of light elements to occur. Hydrogen formed first. A proton was the first thing to form after the Big Bang. So first we have hydrogen, then we've got a couple protons and neutrons running into each other, and we can get helium and lithium. But these were the first things to form. And so there was a ton of them. So conditions were just right. And a lot of that gas from the Big Bang is still left behind. So we still see all of this hydrogen, helium, and lithium just everywhere you look in space. So that's piece two, is the high concentrations of these light elements. The third piece of evidence to support the Big Bang is something called the cosmic microwave background, or the cosmic microwave radiation background, or something along those lines, some combination of those words. Some people say it differently. Sometimes it's just called the CMB, for cosmic microwave background. If you were to look at the entire universe in in microwaves, it says it right there in the title, it would look something like this picture. This is from the WMAP exploration, and this shows the temperature of the universe. And that looks like there are a lot of wide variations, right? You've got some bright red and some really deep purple. This has been fine-tuned very, very nicely to show you the fluctuations. Everything in here is about 2.7 degrees Kelvin. Remember, absolute zero is 0 Kelvin, and that is where it is so cold that nothing is able to move at all. No electrons are moving around protons. Everything stops. So the cosmic microwave background is only 2.7 Kelvin, which seems incredibly cold, and it is, but it's still considered background heat because it's not zero, because there is warmth, there is some kind of heat just in the background of space. And what this background radiation is the leftover heat from the beginning of the universe. When everything was in that tiny dense ball, it was really, really hot. When things compress, they get warmer. So when everything was really, really tight, it was really, really hot. As the universe expands and as things spread out, they can cool down. But we see this background heat. So we can see it hasn't cooled all the way down yet because things are still expanding, things are still growing. So when we look at the cosmic microwave background, it's this leftover heat. It is after you blow out a candle and you hold your hand near the smoking wick, it still feels warm. Even though the candle's not lit anymore, it's still warm. When you take a plate of food out of the microwave, nothing is actively warming it anymore, but it's still warm. You can still feel it. After you put out a fire in the fireplace, the logs are still hot for a little bit. That's what this is. This is the leftover heat as things are slowly cooling down. So this is the third and one of the biggest pieces to support the Big Bang Theory explanation of the universe. So those are the three pieces of evidence. Everything is moving away from each other, or Hubble expansion, the high concentrations of these light elements, hydrogen, helium, and lithium, and the cosmic microwave background radiation. And that's it.